Hello and welcome to my video, lesson 3.3, about decimal multiplication. So I'm going to start off with going through the basics and the most basic examples of decimal multiplication, and then draw some parallels between whole numbers, and then I'll show you the most complicated example for this topic, at least for grade 6. So we can do 3 times 1 pretty easily, right? 3 times 1 is just going to be 3. That's not a problem. But if we have 0.1, something's going to change. And this is what makes decimals interesting when we're multiplying. It actually will make our numbers smaller. So normally in multiplication, everything gets bigger. When we're multiplying by decimals, it gets smaller. So in this case, 3 times 0.1 is going to be 0.3. And the same sort of logic is going to hold true for all all sorts of, doesn't matter where your decimal is or how far along our place value we are, this is going to hold true. So if we do 7 times 0.01, it's going to be 0.07 as our answer. So we just need to follow down our columns and we will get to the right answer. And so when we're doing regular whole number multiplication, you follow down your columns. So the only difference here is just to make sure that you're very aware of where that decimal is and you're keeping track of it and putting it in the exact same spot. Okay, so let's just think about these. The one on the left, 3 times 0.1, as 1/10. Okay, so this here, 0.1, is the same thing as 1/10. So if you have 1/10 of a pizza, you could just draw that, right? Drawing, I mean, I'm not going to be very, not like that. 1 down, but then we need to have like, is that 5? 1, 2, 3, 4, 5. Okay, I mean, it's not perfect, but you know. There you go. So it's not evenly sliced, but let's say that's our pizza in 10 pieces. Now, if I take 1/10 of that, I could say that's 0.1 of the pizza. Okay? Now, remember that multiplication is just repeated addition. So if you did 0.1 plus 0.1 plus 0.1, all we're doing is instead of having 1 slice of pizza, we have 1, 2, 3 slices of pizza. So altogether, now we can say we have, I don't know, let's use red. If we do repeated addition, it's like multiplication, 0.3. Okay, so that's one way to think about it if that helps. Hopefully that helps. Okay, let's go down here to a slightly more complicated example, and then we will go into a different way of looking at it as well. So let's try this here. 8 times 0.12. So 8 times 1 is going to be 8. Right? So I'm going to just put that down like this. And then 8 times 2 is 16. Now the trick here is to be very careful to put the smallest number, so the 6 part of the 16, the lowest number on the place value. So the 6 part of 16, place it right where that digit was. So where the 2 is, in that same spot we're putting that 6. I don't know if that is clear enough for you, but hopefully that helps. And then, oh my goodness, my touchscreen is going wonky today. And then, just like we would in a bigger multiplication example of whole numbers, you're going to add them. So 0.8 plus 0.16 So it's going to be 0.96. All right. And let's try the next one. So normally I would start with the right-hand side, so I didn't do this time, but let's try it here. So 6 times 5 is 30, but keeping it in mind where it is. 6 times 1 is 6. 6 times 1 again is 6. Now we're going to add them all together to get 6.90, or you can just write 6.9. All right. This is the most accurate and most consistent way of getting the answer. But if you don't like this, because the decimals really scare you, this is another way you can look at it. So we call it, I call it estimate and compare. So just estimate it or change it to a whole number. So let's go 3, 5, 7, okay, times 2. And then let's go down. So 2 times 7 is 14. 2 times 50 is 10, or is 100, I guess. 2 times 300 is 600. And now if we add it all together, 714. So that's our whole number comparison. And if we were to estimate it, then we could estimate the top one to be 4 times by 2, right? So this rounds up the 3 to be a 4 times by 2, so that would be 8. Okay, so where could we put the decimal? In this number here, hold on. In this number here, where can we put the decimal in order to make sure that it looks closest to an 8? If I put the decimal here, it wouldn't look like an 8. It would look like a 71 or 72 or something like that. If I put it at the end, it would be 700. That wouldn't be right. If I put it here, it would be less than 1. That's not right. If I put it here, now we're good. Okay? So this might be another way. If the other way is confusing you, maybe this estimating and comparing, so this estimate and then comparing to this might work for you. Okay, let's try it again here. This time I'm just going to go down with the numbers like this. So 3 times 3 is 9. So I'm just imagining that there's no decimal there. 3 times 20 is 60. 3 times 7 is 21. Making sure I have all my correct zeros. Adding that all up to 2169. And then if we were to estimate, this would be 7, 3. So if we multiply those together, we have 21. So if we're comparing from here to here, where should I put the decimal so it looks closest to 21? Well, I should put the decimal right there. So if that helps, this is another way to keep track of where to put that decimal. You can use either method, either the one that I just did above in green or this purple and blue method. Feel free to try it one way, try it another way, see what you like best, and good luck with decimal multiplication.